stop, format it, touch it, bring it, space, watch it, turn it, leave it, stop, format it, touch it, bring it, space, watch it, turn it, leave it, stop, format it.
Let's go. Okay, learning target. I how to understand the connections between proportional lines and linear relationships. So we were doing Wednesday, December 5th, day 19 specifically. I will read it aloud. I will read it aloud and I will focus on some specifics. Okay, got my magic. Okay, so the graph to the right. The graph to the right. It shows relationship between the distance run, and the time for three people and 100-yard dash. Okay. Now we're told about Kofi. Kofi, we know a little bit about Kofi. We know that Kofi, okay. Go ahead, Kofi. You can close now. Oh, here we go. We know that Kofi is has a rate of change of 15.55. Okay, and what we don't know is what Bella and Essie have. Okay, so I'm going to give you guys a way of kind of thinking about this. All right, I want you to imagine that we have a rock, and I'm rolling the rock down the hill called Big Bella, and then I roll the rock down the hill called Big Kofi, and then I rolled the rock down the hill Big Elsie. Which hill will the rock roll the fastest? Well, if you're like most people, you're going to say that the rock is going to roll faster on Big Bella because it has the steepest slope. All right. Second fastest is Kofi. Third fastest is Ellis. So what that means is if Kofi is 15.55, I need Bella must have a greater slope or a larger slope, and Elsie must have a slope that is slightly smaller than 15.55. Okay, so if we got that far in our thinking, the rest is going to be easy peasy. Take a look at the solution. In the solution, I've highlighted everything related to Kofi in blue. I've highlighted everything related to Bella in red. And I've highlighted everything related to Elsie in black. So A is wrong on all levels. No partial credit there. B is partially correct. C is partially correct. The only thing that's 100% true is choice D, because the other choices are either false or half false. So in other words, my best shot is to understand that Bella had to be bigger than 15.55 and Elsie had to be smaller than 15.55. And I get the best of both worlds in D. Let's keep it moving. Another car example. This time the car is leaving from Rochester, traveling to Buffalo, but I'm living based on this equation here. 93 is my y-intercept, my initial value. My rate of change is negative, which means I'm going down. And I need to know what the y-intercept means. Well, in the context of the story, the y-intercept simply means that we're 93 miles closer to New York City than we are to Rochester. Closer to, no, hold on, let me say it again. We're 93 miles closer to New York City Okay, no. Let me say it differently. Um, Let me say it like this. So if this is Buffalo and this is Rochester, okay, and this is New York City. And all together we're doing 330 miles, I think. 330. All right. And that is the space from here to here, space from here to here. Okay. And what we're doing, oh, that my magic pen. What I'm asking you guys to consider is this. Okay. We know that Rochester and Buffalo are about an hour from each other. Okay. So what we're saying is that, okay. So if this is 0, this is 0. Okay. That's 0, and that's 330. And my rate of change is going down. That means instead of starting at 330, I am starting 93 miles closer to Rochester. So that means 93 miles would be right here. Okay, so I'm starting 93 miles. That's my starting point. Starting at 0, starting at 93 miles, and I'm going down. So the context of the story is 93 miles is my y-intercept, my initial start time, and I continue to go down 60 miles every hour. Okay, I hope that helped out. Let's see, how about this one? Okay, Thursday. Okay, which substance uh, is represented by this? Okay, I will tell you, I thought I did this. Yeah, let's bring this out because this will simplify my explanation. Take a look. Okay, I'm looking for a slope of 3. All right. All right, my rise is 1. My run is 3. That's 1 over 3. That's not close enough. Looking for a slope of 3. My rise is 4. My run is 2. That's not close enough. That's 2. 2 is not equal to 3. Again, looking for my slope. My rise is 3. My run is 3. That's 3 over 3. That's not 3. That's 1. And finally, I get to this guy right here, D, my final choice. My rise is 6. My run is 2. 6 divided by 2, guys, is 3. 3 is the number I've been looking for. 100%. That's what I want. Okay. And let's take a moment and just look at the last one. A company that manufactures walkie-talkies first pays a startup cost and spends a certain amount of money to manufacture each radio. If the cost of manufacturing a walkie-talkie is given by a function, that function is C of W equals 4.5 W plus 175. What is the value of 4.5? What does that represent? Well, let's take a look here. I would suggest that 4.5 represents the amount in blue spent to manufacture each walkie, and 1.75 I would suggest is the original startup cost. 1 and 2 are dummy choices. They are meant to help you, just distract you. In fact, we call those our distractors. Okay, that brings me to the close of this session for math mentoring. Uh, understanding relationships or connections between proportional relationships, lines, and linear equations. Obviously, we want you to keep this video such that you can review it, internalize it, learn it. 30 minutes, study a day, keeps our bad grades away. That's all I got for you. Peace.